Hey everyone. In the world of IT security, it often feels like there's this constant tug of war between locking everything down tight and, well, actually getting our work done. Today, we're going to dive into a perfect example of that, a clash between one of Microsoft's most powerful security features and a tool that tons of IT pros rely on, Patch My PC.
So here's the game plan. First, we're going to talk about your digital attack surface. The very reason these security tools even exist. Then we'll look at Microsoft's specific shield and the security versus productivity headache it can sometimes cause. We'll get into the weeds on why that conflict happens, and then, most importantly, we'll figure out how to find that perfect balance.
All right, first up, before we can really get into the conflict, we have to understand the battlefield itself, your digital attack surface. This is the whole why behind being proactive with security in the first place.
So, what is an attack surface, really? Just think of it like this. It's every single possible way an attacker could try to get into your network. Every laptop, every server, every unpatched app, every open port. Each one is like a potential door or window into your house.
And this is exactly where attack surface reduction, or ASR, comes into play. It's really just the simple but super powerful idea of going around and methodically closing all those digital doors and locking those windows. The fewer chances you give an attacker, the safer you're going to be. It's a total shift from just reacting to threats to actually preventing them from ever getting a foothold.
And if you're wondering why this is such a huge deal, just look at the money on the line. The FBI reported $16 billion in losses from cybercrime. And get this, that number jumped 33% in just 1 year. A number that big really changes things, right? It makes ASR not just some techie best practice, but an absolutely crucial financial strategy for any business.
Okay, so with that pretty scary context, let's look at what Microsoft gives you to fight back. How does Windows itself help you shrink that attack surface right out of the box?
Well, Microsoft Defender comes with a whole suite of these ASR rules baked right in. You can think of them as these built-in tripwires that are specifically designed to spot and block the common tricks and techniques that malware loves to use. It stops attacks before they can even really begin. Now, there are a ton of these ASR rules, and they cover everything from funky Office macros to sketchy USB drives. But for this explainer, we're going to zero in on one very specific rule, the one that blocks credential stealing from the Windows Local Security Authority subsystem, or LSSS. Just think of LSS as the digital Fort Knox inside Windows, where it handles logins and passwords. Protecting it is non-negotiable. But this rule, this is where our story gets complicated.
And that brings us right to the heart of the matter, this classic tug-of-war between security and productivity. It's a situation where a really good security rule ends up making a really good IT tool look like a bad guy.
You don't have to take my word for it. This quote from Patch My PC themselves just nails the problem. These security rules are designed to be aggressive, right? But that same aggression means they can sometimes flag totally legitimate actions, especially from tools that have to operate at a really deep level of the operating system.
So let's be crystal clear about who's in the ring here. The conflict we're dissecting is between that super important ASR rule that protects LSAS and the update processes run by the incredibly popular third-party patching tool, Patch My PC.
So why? Why does this even happen? Let's pop the hood for a minute and look at the technical reason for this false alarm. It's actually a pretty fascinating peek into how Windows security really works.
To get what's going on, you have to know about two different worlds inside of Windows, the system context and the user context. Think of the system context as the engine room of a ship. It has the highest level of privilege, and it handles all the core stuff, like installing software. The user context is more like the ship's bridge. It's what you, the user, see and interact with. Your desktop, your apps, all those notifications.
Okay, so follow me on this. Here's what happens. First, Patch My PC kicks off an installation down in that powerful system context, the engine room. But to do its job right, like to see if you have an app open that needs to be closed, or to show you a pop-up, it needs to talk to you up on the bridge, in the user context. To cross that boundary, it uses a standard, totally legitimate Windows function. The only problem is, that function needs to grab the user's security token to make the switch. And that specific, necessary action is what makes the ASR rule's alarm bells go off.
Now, I have to be super clear on this point. Patch My PC is not doing anything malicious here. It is not stealing credentials. It's not trying to dump the LSS memory. It is simply performing a well-documented, secure, and necessary operation so it can manage software updates. This is a textbook false positive, where a good tool's normal behavior just happens to look suspicious to a very aggressive security rule.
And these are the 3 specific files that are involved in this whole process. But the most important thing to see on this slide is that all of them are code signed by Patch My PC. A code signature is basically a digital, tamper-proof seal. It's the cryptographic proof that these files are the real deal, straight from the developer, and haven't been messed with.
So we get the problem. The million-dollar question is, how do you fix this without just turning off a security feature you really need? Let's talk about some real, actionable solutions for finding that balance.
The solution is to create exclusions. But, and this is a big but, there's a catch. For this specific ASR rule, you can't just tell it to trust everything with a Patch My PC signature. That'd be too easy. Instead, you have to use path-based exclusions, which means you have to tell Defender, hey, ignore these specific files when you see them in these specific places.
This table basically lays out your choices, and it's all about that trade-off between how secure you want to be and how easy you want it to be. You could go with a relaxed approach using wildcards. It's super easy, but not very specific. You could go very strict and lock it down to a very specific folder. That's the most secure, but it's a bit of a pain to maintain. Or you can take the stricter approach, which is the sweet spot right in the middle.
And honestly, for most organizations out there, that middle, stricter option is going to be the way to go. It specifically names each file, which gives you really solid security, but it saves you the headache of having to specify every single possible cache location. It's the practical, get-it-done choice.
And if we just kind of visualize how different IT teams might break this down, it's pretty clear that a balanced, thought-out choice is the most common. You'll see half of the teams landing on that stricter, balanced exclusion, while others might lean toward maximum security or total simplicity, all depending on their own tolerance for risk. And all of this leaves us with one final thought. Real, effective security isn't just about being strict for the sake of being strict. It's about being smart. It's about balancing those powerful rules with intelligent exceptions. So the question I'll leave you with is this. Take a look at your own security posture. Is it truly balanced or is it just strict?